Naive-Bayes classification. Naive-Bayes method is a supervised learning algorithm based on Bayes' theorem. It is called naive-Bayes classification because it is taking the naive assumption of independence between every pair of features. This is a basic Bayes rule which is related to probability. Probability of B given A equal to probability of A given B into probability of B divided by probability of A. This is the basic Bayes rule. And Bayes algorithm is based on this Bayes rule. Let's start with an example. Suppose a data is given like this. Based on the weather condition, the child is taking a decision whether to go out to play or not. So target variable is yes or no, and we have only one input column in this example. We need to classify whether players will play or not based on weather condition. So we can state the problem like this. Given this data set, players will play if weather is sunny, is the statement is correct. Or in other words, we want to compute the probability of yes given weather equal to sunny. So probability of yes given sunny can be calculated using Bayes rule like this. Probability of yes given sunny equal to probability of sunny given yes into probability of yes divided by probability of sunny. And from this table, it is easy for us to find out the individual probability values. So for preparing the probability values, first I have created a frequency table based on weather condition, different weather condition, what is the total number of no and yes. So with this table, it is easy to obtain the probability of the individual items. So let us see. We will start with, we want to compute probability of yes given sunny. So we want to compute the probability of two terms. First one is probability of sunny given yes. Probability of sunny given yes equal to 3 by 9, because 3 times he has taken the decision yes when the weather was sunny, and the total number of his yes decisions is 9. So probability of sunny given yes equal to 3 by 9 equal to 0.33. Now probability of sunny is equal to 5 by 4. 5 times it was sunny, and the total number of entries here is 14. So probability of sunny equal to 5 by 14 is equal to 0.36. Now what is the probability of yes? Out of the 14, 9 times he has taken the decision yes. So that's probability of yes. So apply these variable values inside the equation. We will get probability of yes given sunny equal to 0.33 into 0.64 divided by 0.36, which is equal to 0.6. So this is greater than 0.5. Actually, we are having only two decisions, yes and no. So probability of yes given sunny is 0.6, means the probability of taking a decision of yes is more than the decision no. So probability of yes given sunny has the highest probability. So when the record is sunny, the class will be yes. That's the meaning of this probability of yes given sunny. When the input variable is sunny, the output will be yes, because the probability of yes given sunny is 60%. Okay, so this is a basic idea of Bayes rule, and this can be applied when we are having multiple columns. So this is a mathematical representation when we are having multiple columns. Probability of y given x, where x is a vector having more than one columns. So probability of y given x equal to probability of x given y into probability of y divided by probability of x. So we expanded. If any two events A and B are independent, you know probability of AB equal to probability of A into probability of B. So in a naive-based classifier, we are taking an assumption that all the individual variables are independent. So we can write probability of y given x1, x2, etc. xn equal to probability of x1 given y, probability of x2 given y, etc. up to probability of xn given y into py, the whole divided by probability of x1, probability of x2, probability of xn. So what we have done is just expanded the vector, and with the help of this theorem, we are multiplying the probabilities, assuming that the individual probabilities are independent. So it can be written in this form as a product of probability of xi given y divided by probability of x1, x2, etc. xn. Now, our objective is to find out into which class this x1, x2, etc. will belong. That is, what is the probability of y given x1, x2, etc. xn. So again, this right side can be again simplified into probability of y given x1, x2, etc. is proportional to probability of y into probability of xi given y, and then pi of I equal to 1 to n probability of xi given y. We are ignoring the denominator here, assuming that for any class the denominator will be the same. So we can just remove that and write it as the probability of y given x1, x2, etc. xn is proportional to probability of y into individual probability of xi given y. So using this equation, the Bayes algorithm will work, and it will find out the most probable class for a given input. So mathematically it is obtaining the result. It is based on probability values. So we have seen many algorithms for classification, and we have seen that in KNN classifier it includes mathematical computations to find out the distance between the points, and in logistic regression it follows a curve. That's also mathematical computation. Now when we use decision trees, actually we are not doing any calculation, but this decision is based on the tree. And in name-based classifier also there is no distance calculation as such. So when to use name-based classifier? When the dataset is moderate or large training dataset, this can be used. Attributes that describe instances are conditionally independent. We can use this classification because in this naive-based classifier, we are taking an assumption that the individual columns or individual features are independent. The successful applications are in diagnosis and classifying text documents. Okay.